Alrighty, first things first, we're going to hop into our Darknet folder. So wherever you cloned and built Darknet, we're going to go over to this folder. If you don't already have Darknet installed, you need that in order to run YOLO and create this custom object detector. Luckily for you, I have a previous video where I do a complete walkthrough of how to download and install Darknet with YOLO version 3 in order to do these object detections. So I'll link that down below in the description. So check that out if you haven't already. So first things first, the first part of our custom detector is going to be to get the data set. So we're going to go into data and then just create a new folder, and we're going to call this obj. So this is for the object folder where we're going to store all of our images. And now you're going to open up a PowerShell, and you're going to see that I've done this already. But what you're going to do is you're going to want to check out my previous video on gathering a custom data set, where I actually go through how you can use Google's Open Images dataset, which has over 9 million images, and it has 600 predefined classes. So pretty much anything you're going to want, you can find here. So you can do anything from bee, so we got bees, all types of animals. The ones I'm going to go over today in my dataset are actually going to be really cool. So there's actually a weapon dataset. I know it's kind of scary, but it's actually really cool because it has more practical implications. So you could put this into a security camera, for example, and help pick up weapons in like a public place or at your personal security at your home. So I'm actually going to use this as one of my custom detectors. People also love this data set for doing aimbots for whether it's CSGO or other video games. They can actually do aim assist and aimbots using YOLO version 3. So if you want to see that, let me know. And then I'm going to have two classes. So I'm going to do weapons, and I'm also going to use the data set for aircrafts. So this is another practical implication where you could be trying to, at an airport or no-fly zone, count how many aircrafts you have in your airspace. So these are the two data sets that I'm going to combine for my custom detector. But you can go ahead in here and find anything. Like there's also a bunch of human parts. So you can do human arm, eyes if you're trying to like find someone's eyes in an image. You can do the head. Like you can detect any part of the human body pretty much in this data set. So that's also a very popular used one. So now I'm going to open up my toolkit that I showed in my previous video. I'll link down the description to my repository where you can download this code as well. So I ran Python main.py downloader, and I chose my classes aircraft and weapon. And my type CSV is train because I wanted the training data set. And I've grabbed 1,000 images of each, and I set multi-classes to 1 so that both of them end up in the same folder. So if we go and check out the folder, we go down to my data set, train, aircraft, weapon, and you can see that it's combined them. And there's like 2,000 images in this folder now. So I already have my custom data set made in minutes, and I've already downloaded that. And I've also ran this convert annotations.py from the root folder here, and that's actually gone ahead and generated my annotations and labels for my custom detector so that my data is already ready to be trained on. So all I'm going to do in here is do Control A, and then just Control click on this one to deselect the labels. Those are the old labels, and I no longer need them. So I'm going to do Control C on this whole thing, go back to my data, go to my object, and just Control V this in here. So it's going to take a little time. One thing to point out and remember is that inside of your toolkit, you need to make sure that you change the classes to whichever classes you choose to download in order to make your custom detector. This is crucial because you're going to have to make sure in the Darknet repository that this matches a certain your classes.txt file, which we'll get to shortly. So we head back to this. We see everything's downloaded. So now we can go back out of here, and now we can start to configure the rest of our custom detector. So now that our images are handled and we have our custom data set, we now need to go and make our custom config file. So we're going to go back to the Darknet root repository, and I'm actually going to go ahead and open all of this up inside of VS Code so we can actually quickly edit files. So I already have this in Darknet. I'm just going to do code dot, that'll open up VS Code. So we're going to see that this opens. That's an old file. And now, okay, so we're going to go scroll all the way up. This is actually where we want to go. We're going to go into our config, and we're going to go find YOLOv3.config. So this is the one that comes pre-ready to run on. And we're just going to go ahead and change this. We're going to comment these 2 lines and uncomment the 2 training lines. And now we're actually going to go File, Save As, and we're going to save this as YOLOv3 underscore, or I'll just do dash custom. And let's do .config. We're going to save that. And now we have our YOLOv3 custom.config. And it's not quite finished, so we're going to keep going. So we have our batch set to 64, which we uncommented. And we have subdivisions equal to 16. My computer can't actually handle 16, so I'm going to change that to 32. I recommend starting on 16, and if you get a CUDA error out of memory, up this to 32. And if you have to, again, up it to 64. So now we're going to save, and we're going to head down. And now this is our next line we're going to change. So max batches is how many times our training is going to run through the data. So how many batches we're going to go through. And usually for this, you're going to want to change this to 2,000 times however many classes you have. So I'm going to run with 2 classes. So I'm going to set this to 4,000. And so if I did 3 classes, I would do 6,000. 4 classes, 8,000, so on, so on. But if you're just trying to detect 1 class, it's recommended that you keep this at 4,000 as a minimum so that it has enough time to train and actually do proper detections. So if you have 1 class, keep this at 4,000. So next, we got to change our steps. So you want to change your steps to 80% of your max batches and 90% of your max batches. So I know off the top of my head that 80% of 4,000 is 3,200, and then 90% of 4,000 of our max batches is going to be 3,600. So now we've set that, we've set our steps, and now we're going to head back down and now start changing a couple other lines. So you're going to want to, at this point, do Control F, and you're going to look for YOLO. And this is going to find our YOLO layers within our network. So you're going to see that it has classes. This is set to the Coco dataset that has 80 classes. Our custom one's just going to have 2. So I changed that to 2. And then there's 3 of these. We're going to do 3 of them. But you also want to change the one convolutional layer above each of the YOLO layers. So you find YOLO, and then you go to the convolution above it, and you're going to change this filters attribute. So we're going to change this to an equation that'll pop up on the screen. It's classes plus 5 times 3. So I'll pop that up on the screen. And for us, since we have our classes number is 2, we're doing 2 classes plus 5, that's 7, and then times 3. So our filters are going to be set to 21. If you were doing 1 class, this would be 18 because it would be 1 plus 5. So number of classes plus 5 times 3. So that'll be 6 times 3, so that would be 18 if you have 1 class. So we're just going to keep going down and finding our other YOLO layers. So that's the one we just found. Here's the second one. Change it to 2. And once again, change the filters to classes plus 5 times 3. So 21 for us. And then we're going to head back on down to the third YOLO layer. And we're going to change that to 2. And once again, filters to 21. We're going to go ahead and save that. Perfect. And finally, the last change we're going to do inside our config folder is Control F and look for random. And we're going to set each of these to 0. So setting random to 1 resizes each one of your images as it trains it so that it doesn't like overfit on a 416 by 416 image. because that's what it resizes every image to before it does the training. But for me, my computer can't handle when it goes larger than 416 by 416, like into like a 600 by 600 pixels. It always gets an out of memory error. So you can try with random equals 1 as well, but if you get an out of memory error, then you're going to want to go ahead and change all 3 of these randoms to 0. So I'm going to go ahead and do that. There's 3 of them. So now we can go back up to the top and our config should be finished. So we've commented both the testing lines and we've set them to training. So batch equals 64, subdivisions to 16. If you get an CUDA out of memory error, then you up this by 2 to 32. If you get an error again, to 64. And now we've set our max batches to 2,000 times number of classes, or a minimum of 4,000 if you're running with one class. We've done our YOLO layers and as well the filters for each layer above the YOLO layers. So we've done our config and it's ready to go. So now we're going to want to go ahead and create some custom object files which help us point to which files we need to be looking at while we run our custom detections. So we're going to go ahead and just go to our data folder. So we find, oh, that's not it, our data folder, and then go new file. And this is going to be called obj.names. You can actually call this whatever you want, but I just stay with the object, similar to our file that these are in. And then this is where I said you have to go and look at your classes.txt in your toolkit. So I have aircraft and weapon. Since our annotations were created in this order, you want your object.names file to be the exact same. So I had aircraft and weapon on the second line. You want to make sure it's in the same order. I'm just going to go ahead and save, and that's all you need in the object names, just your classes and 1 per line. So now that that's done, we're going to go ahead and create a new file also in our data folder, and this one's going to be called obj.data. And this is going to point us where all of our data is. So it's going to look like this. It's going to look like classes equals to your number of classes, so 2 for me. Then it's going to be point to where your training data is. So ours is going to be held, you'll see in a sec when we create it, under data/train.txt. And that is the path from the root Darknet folder. So that's why we put the data in front of it. Validation, or actually I'm just called valid, equals data/test.txt. I am going to manually just run on other images that aren't in my training custom data set to validate. But if you want, you could create another image data set that it would actually test on. So this is where you would put the names of your images that you'll see in a sec. We do for training, for validation if you so choose, but I'm not going to do it, and you'll see that it works just fine. And then we point to our names, and that's where the file name you just created. So it's going to be data/object.names. And finally, we're going to choose a spot where we're going to be saving our custom weights folders to. And I'm just going to do this as create a folder called backup and point it to it. So we're going to go ahead and save that. And now I'm going to open up my Darknet, and I'm going to go ahead and, before I forget, I'm going to go and create that backup folder that my weights will end up being saved to. So this is where we'll go to find the weights folders for our custom detector. So now comes the time that we need to create a list of the file paths to all of our training data that we put into our data and obj. So luckily for you, I have created a script that will actually look through this folder and find the file paths for all of these images, and we'll create the txt file that you'll see that we need. So I will actually put that in my GitHub, link it down below. It is, if we scroll down in here, this generate train file, so I can open it up for you guys. So generate train, it's a super simple. If you want to just copy it down, you can, or you can clone it. I will post it on my GitHub, as I said. So we can actually go back. We'll go to the command shell, and I will cd out and cd darknet, and I will run this command. Make sure to put Python in front of it. Python generate train, and it will look exactly like that file, and boom. So if it see no error, you're just going to want to go to your darknet, and it'll end up being in your data folder. So, oh, we have a train.txt, and I open it up, and it should look something like this. It should have the file path of every single one of your custom dataset images. And this is where our training will point to find the images that it's training on. So this is perfect. It looks like it's working. They should all be in there. And that means that the script that I created worked and it's now populated. Because if we didn't have that script, you would have to manually, like if you have a small data set, you can manually put them all in, all the file paths, but you don't want to do that. And once again, the file paths are relative to the root directory. So this is the path from the root Darknet directory. So now comes the time for the final step before we can start to train. So you're going to want to go ahead and we are just going to look up YOLOv3 into Google, the first link. It'll bring us to the official site of the creator of YOLO version 3. And you're going to scroll on down. It's near the bottom. We need to get a preset weights file for all of the layers in the network for YOLO version 3. And this already has all the weights attached to all of those convolution layers that we saw before. So it's going to be way down here, and it's going to be right here. So if you just Command F, download pre-trained convolutional weights, this is the network architecture and all the weights associated with each of those convolutional layers that we saw in the config file. So it's going to be this link here, and we're just going to go ahead and download it. And we're going to wait for the download, and then we'll come back. So once it's downloaded, we'll see it in our downloads. We'll just click on it, Control-C, and then we'll head back to our root directory and just Control-V, and we'll see it in there. I have had an issue in the past where when I paste it in, it loses this second, like after the conv, it loses the period, the dot, and it just says conv74. And if that's the case, that'll actually cause an error. So if you're getting an error saying can't find darknet53.conv74, it's because it's taken away that dot. So just rename the file with the dot in it and it'll work. So now comes the time to actually do our training. So you're going to open up your shell or command prompt to your Darknet home root directory. So that's where we are. And now you're just going to run this super simple command, /darknet.exe. If you're on Linux, you don't need the .exe. And then it's going to be similar to our testing command. It's going to be detector train. And now you're going to point it to the first parameter is to your object.data. The second is to your config file. So ours is config YOLOv3-custom.config. And then the third one is going to be the pre-trained weights. So we're going to point ours to darknet53.conv.74. And we're going to go ahead and now run this. So it's going to go ahead and hopefully load in all the weights as you're seeing right now. And then it's going to start to go through the batches and actually start to train. So you're going to see that this chart pops up. And this will actually, if we minimize it a bit, this will keep on updating as it goes through each iteration. And it has the iteration number that it's on. It will have a number here once it starts going. There we can see it. Iteration is on 1. And it shows you your current average loss of your model. So right now you can see that our loss is huge. It's at like 945. This is normal. It can be in the thousands to start with. And you'll see that as it gets to around 200, 100 iterations, it'll actually hopefully get down to under 5 by then. And hopefully by the end of training our model, our loss is below 1 and it will be a good detector. Sometimes you can even get good detectors with a loss under 2. It really depends on the scenario and all the training data you give it. So it's on iteration 4 of 4,000. So as you can see, this is going to take a fairly long time. It actually can take hours and hours. So I recommend if you're like going to work for the day, just to leave this running, or as you go to sleep one night, leave it running. And actually, if you go to your display settings, so you're going to go to display, or it's actually just settings, and you're going to go to your power and sleep. You're going to want to plug in your laptop and then change this setting to never. And same with here, when plugged in, go to sleep never. And as long as you have your laptop plugged in and these on, your computer won't turn off and it will keep running for the entirety of it. One thing to notice is if we open up our PowerShell, you're going to see that it's just running through and you're going to keep seeing, and every once in a while we can scroll up and see that it's going to print out that it's on iteration 8 and the loss and how long it took. So it's taking 13 seconds average for each batch of 64 images that it takes in and trains on. So yeah, it's going to take a couple of hours at least to run. One thing to notice, if for some reason you don't set those settings on your computer and your computer turns off, the file that you decided to choose to save your weights to, so for us, I showed you we chose backup. Every 100 iterations that it goes through, it's going to save the most up-to-date weights folder in here, so that if for some reason your thing crashes or goes down, it'll have that weights saved, and you can actually train from those weights, like restart at that checkpoint and not lose all of the time that you spent training. And it'll also save a folder here, as we'll see at the end, for every 1,000 iterations. It'll save an additional weights folder for you. So our thing is going ahead and it's training on both the weapon data images and our aircraft images. So hopefully we'll come back when this is done training. I'm going to let it run overnight and it'll be done in the morning. And I'll show you guys the results and I'll show you guys how to then do the testing detections on other images that I'll just pull from Google to show you guys that we have successfully custom trained a YOLOv3 custom detector. Alrighty, so it's the next day now and I've let this run overnight and it's now finished. So as you can see, it's gone through the 4,000th iteration, which is what we set the max batches to. And it's seen 256,000 images over time. So that makes sense because we set batch size to 64 for 4,000 iterations. If you do that math, 4,000 times 64, it's 256,000. You can take my word for that. So it's gone through our data set so many times. It's looking at the images probably hundreds of times each, and it's saved the weights. So as we can see, it's saved the weights to our backup folder. So if we go into our Darknet, look in our backup, we can see all of the saved weights throughout the training process. So like I said, it's going to save the weights in a new file for every 1,000 iterations. But while you're doing it, every 100 iterations, it's going to save this custom last weights. So as you're going through, for any reason, if anything happens, like I mentioned, you can actually go in here and run the same command you had before, but instead of the Darknet 53 line, you would just put your new weights here. So you would just put your YOLOv3 custom _ last weights, or if you want to reach train from, let's say it ended just after 1,000, you could put your 1,000 weights here and run this command, and it would actually start kicking off your training from that checkpoint. So that's good if your computer crashes or dies for some reason and you're worried about, oh my crap, I didn't finish. You can actually go here and restart the training from certain checkpoints, which is really nifty. So now we're all asking the question, so how can we test to see if this is working? We'll get to that. But you can see first that our loss is actually quite low. It ended at 0.35 from starting at somewhere over 900. So that's pretty crazy. And if you want to get a visual representation, you can just go back to the root directory and scroll down. I have some images here that we're going to check on in a sec to test, and go to the chart PNG. So throughout the process, every iteration, it'll save the chart PNG, and this will show you guys the loss over time for every iteration. So you can see it took around until probably around 250, 300 iterations for it to get below this loss of 5. So before that, it was off of the chart. So you can see it's going to go down, it's going down quickly, and then it starts to steady out, which means the training isn't doing as much per iteration anymore because it's done a lot of the training, but it's still going to get lower and lower, and pretty much all the way until the 4,000th iteration, it was at least still going down, which is good to see. And like I said, the lower the loss, the better your current custom object detector will be. So looks like this one should be pretty good to distinguish weapons and aircrafts. So now we're going to go into actually checking it out. So a last final tweak we have to do before running our custom detector is opening up our custom config file that we made, so YOLOv3-custom.config, and we're just going to go and comment the 2 training lines for batch and subdivisions and uncomment the testing ones. So this will allow us to check and test on a single image that we can send to our detector. So we're going to go ahead and save that, and now we can actually go ahead and run our detector. So here we go. So this is the command you're going to want to run. So you're going to run, you've seen this before, it's /darknet.exe detector, and then instead of train, we're going to do test, and then we point it to the same stuff. So our data/object.data folder, then our config, our custom config that we just changed back to testing mode. And then you can point this at any one of your weights files to see your custom detector. But obviously, if you want to point it at your last weights, or the _final, that one works too, or the _4000. And for some reason, if you think that if you go back to your chart, that your detector kind of steadied out too early, like maybe somewhere over at 2000, and it was going straight across, and you think that maybe your model might have overfit, which means it got too used to your data set that it can only detect images from your data set, then you might want to go back and use one of like the 2000 weights. Check that out. See if that's actually a better detector. It's pretty much just trial and error to see what's the best, but obviously it's going to usually be, if you're steadily going down and down for your loss, it's going to be the 4000 weights one, so that will be the last or final weights that get saved. So if we open up our detector again, jet.jpg is, if I open it up for you guys, it's just a image of a plane that I just took off Google Images. So that's where I'm getting these test images from, because I don't want to use one of the ones from the data set itself. You want to use a different image. So let's actually go ahead and run this now. So we're pointing it to our backup folder and our custom weights. Everything looks good. Let's go ahead and click enter. So it's going to load in the weights and then run the custom detection, and fingers crossed, there we go. So that looks pretty sweet. It's detecting aircraft around the jet, which is perfect. So we'll go ahead and run a couple more things here to show you guys that it works. I'm going to run the detector and change it to an image of a gun that I chose. So you're going to see that our detector is going to work pretty well, hopefully. Yep, that's pretty accurate. It's missing a little bit of the edge of the barrel and a little bit of the handle, but it's pretty good at detecting that it's a weapon. And that's saying, if you check actually right below here, you can see that the accuracy value itself. So it's actually 99% accurate that that's a gun. And aircraft is actually, a lot of things fall under aircraft. So we can actually do balloon and test a balloon, a hot air balloon. Technically it's an aircraft because it's in the air. And wow, you can see it perfectly gets the aircraft. We'll run a couple more for you guys here. As you can see, that one was a little bit less accurate, so it probably didn't have as many training images of balloons for aircraft, mostly planes and stuff. Let me show you guys with someone holding a gun. So soldier, this will be an army soldier. And you can see it looks distorted, but if you actually close it and go back to our Darknet repo. After every time, it'll save the most recent detection under predictions, and it'll actually be the proper size. So if for any reason something looks blurry, just open it as predictions, and you'll see that it gets the gun in the soldier's hands. Not sure if that guy's a good guy or a bad guy, actually. Oops. I think I have one more for plane to show you guys, or helicopter, actually. So we go back to the detector, and we put in my heli image. And these images are just saved in the root folder, but you can save them anywhere as long as you point to the proper image. Boom. You can get helicopters as an aircraft. So we're going to run now our custom detector on an actual MP4 video file to show you that it does work in real time with videos. So the command's very similar. You're going to use ./darknet.exe detector, and instead of test, you're going to do demo. And then the same parameters, your object.data, path to your config, and the weights. And then you're going to do the path to your MP4 file. So mine's in my test folder, and it's plain.mp4 is what it's called. And if you use out_file name and then anything.avi, it will save your video with the detections on it for you to check after as well. So we're going to go ahead and run this. And you'll see that it does work on a video. So the same, I'm doing an aircraft, it would work. This is where I'm saying you could do a security camera for weapons or aim assist in video games. People have done that in the past. I just liked this video. It's pretty simple, but you can see that the airplane is getting detected with pretty strong accuracy. It's averaging, it looks like, around 80s to 90s, which is pretty sweet. So your custom detector does work, and it's pretty easy, as you guys saw in this video, to get it up and running. So we're going to wait till the video ends. There we go. Finally, it closes. And then we'll go and check that indeed our results.avi file does save. And you can see that this one is in real time doing the detection. It's showing it in real time at full speed at, like, I think 30 frames per second, because the detections, since my computer is not as strong, I think drops to, yeah, around 12. So if you have a strong computer, you can get it up to 30, but mine's around 12, which is good enough for me. But as you guys can see, we've shown that the custom detector has worked, and we successfully trained for both weapons and aircraft, which is pretty cool. They're both very different, and you can go and just keep adding classes and training again. Like you saw, you can have 600 classes if you really wanted to, but it might take a while to train. So I hope you guys like this video. I'm going to put down in the description below the link to my original Darknet video. So if you haven't installed Darknet, you can do that. And I will do it to the repository for the toolkit to download the images for your custom data set, along with the repo for the script to generate that train.txt easily for you guys. So I hope you enjoyed the video. Please subscribe to the channel so you don't miss out on any YOLOv3 content, because I'm going to have more. And please like this video. It means a lot. And comment down below if you have any issues, and I'll jump on it and help you guys out. Thanks so much for watching, guys. See ya.